Stars don't just appear fully formed, they're born in the cold darkness of nebulae, vast clouds of gas and dust drifting in space. Gravity slowly pulls those clouds tighter until the pressure sparks nuclear fusion, igniting a new star. From there begins the longest chapter of its life, a stable main sequence star, burning hydrogen in a delicate balance between collapse and explosion. This isn't just science, it's the story of how every atom of light in the night sky came to be. And here's the twist. One day our own sun will take that same path. Its birth, its prime, and yes, its death are already written. Want to uncover the full journey of stars, galaxies, and even the universe itself? Make sure you subscribe now because this is only the beginning. The destiny of every star is decided the moment it forms. A small star sips its fuel slowly, glowing for billions of years. A massive star burns hot and fast, living only a few million years before tearing itself apart. Mass is the cosmic judge, quietly writing a star's fate before it even shines. Our sun? A middleweight, destined for a calm, steady burn. But the giants? They live fast, die young, and leave behind the most dramatic endings the cosmos can stage. The universe doesn't deal in fairness, it deals in physics. And mass is everything. When a star like the sun grows old, its core runs out of hydrogen. It swells into a red giant, swallowing nearby worlds and glowing blood red against the black. Eventually, it sheds its outer layers in a dazzling planetary nebula, ghostly shells drifting away into space. What remains is a white dwarf, a dense ember of a once mighty star, fading slowly over eons. It's a quiet death, beautiful but inevitable. One day, this will be our sun's fate. Earth will be long gone, but the echo of our star will still glow faint, stubborn, fading into the dark. Massive stars don't fade quietly, they end in fire. Inside, they build shells like an onion, hydrogen, helium, carbon, all the way to iron. But fusion stops at iron, and without energy to fight gravity, the core collapses in seconds. The outer layers slam inward, rebound, and explode outward as a supernova. For a brief instant, one star outshines an entire galaxy. In that chaos, heavy elements are forged: gold, uranium, even the iron in our blood. From this destruction, neutron stars or black holes are born. Death becomes creation. The universe recycles itself through violence, and everything we are is the ash of those cosmic explosions. Galaxies are alive in their own way. They start small, faint smudges of stars and gas, then grow through endless cycles of birth and death. Exploding stars enrich them with new elements. Collisions reshape them into giants. Spirals twist with delicate arms, while ellipticals swell into bloated orbs. Some galaxies become titans, holding trillions of suns. But nothing lasts forever. When star-forming gas runs out, they begin to fade, their lights slowly winking out. Galaxies are not eternal, they are stories, rising from chaos, thriving in brilliance, and fading into quiet, the echoes of their own past. Some galaxies deceive the eye. From afar, they look like graceful spirals, arms swirling in motion. But closer inspection reveals silence, no newborn stars, no glowing nurseries. They are dead disk galaxies. Their gas has been stripped away or heated beyond use, leaving only aging stars glowing red. They spin, but without life. They are fossils of what once was, preserved in motion but hollow in spirit. Death in the universe isn't always explosive. It can be subtle, a slow suffocation, a beauty locked in place. A galaxy still dances, but its music has stopped. When galaxies collide, they don't pass gently, they rip each other apart. Stars are flung into new orbits, black holes at their centers gorge on matter, and shockwaves of starbirth erupt like fireworks across the sky. Collisions are violent, but they create wonders. Blazing quasars, bursts of new stars, and eventually a single, larger galaxy. Our own Milky Way is fated to crash into Andromeda, and when it does, the night sky will ignite with chaos and beauty. Mergers destroy, but they also create. In the wreckage, a new order forms. That is the universe's way, rebirth through collision. Billions of stars, billions of planets, and yet silence. That's the Fermi Paradox. If life is common, where is everyone? Maybe civilizations destroy themselves before reaching the stars. Maybe they never start. Or maybe they choose silence, hiding from dangers we can't imagine. The great filter looms over this question. Is it behind us? Have we already survived the impossible barrier? Or is it still ahead, waiting to end us? The silence of the universe feels louder the longer we listen. Are we alone, or are we next in line to vanish? Life doesn't thrive everywhere. In galactic graveyards, stars are old, their fuel nearly gone, radiation is harsh, metals are scarce, and new planets are rare. Worlds orbiting white dwarfs or pulsars cling to existence, but these systems are hostile, more prisons than homes. Complex life needs stability, and in these places, stability is gone. The odds narrow with every passing billion years. For all the universe's size, the habitable zones are fragile islands in a vast, dangerous sea. The longer the cosmos ages, the harder it becomes for life to find safe harbor. The cosmos has an ending, but not in fire, in silence. Black holes, once eternal, will evaporate through Hawking radiation, vanishing into nothing. Rogue planets will drift endlessly, forgotten in the dark. Rare bursts of energy may flare white dwarfs reigniting, magnetars flaring, but the trend is clear. Entropy wins. Energy spreads thin, stars fade, and galaxies grow dim. In the far future, only whispers of light will remain before even they are gone. The universe's afterlife is not chaos, it's stillness. The final story isn't a bang, but an endless, empty hush